Okay, so in this section, we're going to look at factoring. So the idea is we're going to take quadratic expressions and we're going to go ahead and factor these. And you've done this before, so it's something that you've seen and done on numerous occasions. We're going to start with some of the basics, and this one sometimes is actually harder than the other ones that we do. Now, with this example, when we factor this, one of the things that we're going to notice is we only have two terms. When we have two terms, what you're going to do is you're going to look for the GCF. Okay? And the GCF is the greatest common factor. The factor is what both these guys are divisible by, and it has to be common. And we're also looking for the largest value, or the greatest. So if I look at these guys, first off, I notice they both have an x. This is an x squared and x, so I can actually pull out an x. So it's not only just the numerical value, but it's also the variable. Now I also look at the 27 and the 18, and I notice that with the 27 and the 18, the greatest common factor is 9. They're divisible by 3, but the greatest common factor is 9. So basically the math is I'm going to divide this guy by 9x and this guy by 9x. That's what we're pulling out. So when we do that, I pull out that 9x. 27 divided by 9 is 3. X squared divided by x is x. And 18 divided by 9 is 2. X divided by x, they cancel out. And I've just factored this. And that would be my final solution. I can't factor it anymore. I've pulled as much out as possible. And if we notice, if we work backwards, if I redistribute, I would be back to my original expression. And so we call it factoring, but it's basically a reverse distribution. So, excuse me. Now this has three terms. And the way that we factor a trinomial is we look at the last number and the middle number. We ask ourselves, what number multiplies to the last term but adds to equal the middle term? So I'll write that down. Multiply to the last term, but also adds to the middle term. Okay? And so I look at the factors of 12. So we want to make sure that they multiply to 12 but also add to 4. So some of the factors of 12, we can think about 4 and 3, but if we add these, and it's a negative 12, so there's no way we can add a 4 and a 3 with a negative in there to equal 4. 6 and 2, yeah, there's a way that we can combine these to get a negative 12 and also add to equal 4. So if I make this a negative 2 and a positive 6, those are actually my factors. And what we're going to do here is we're going to go ahead and separate or factor the 12 into 6 and negative 2. And if we think about going, and this is my actual factoring of this example, and if we think about it backwards, if we went ahead and distributed and we work backwards, so this is actually my answer, but if I went ahead and checked my work and I distributed, I'd get the x squared, the negative 2x, the positive 6x, and the negative 12. And we'll see by checking my work, I'm back at the original expression. So this is the factored expression, and this is the expression in standard form. So be careful with vocabulary also, because I'm going to ask you for the factor terms. And so if I want the factor terms, I'm looking for this piece right here. If I'm looking for standard form, I'm looking for this piece right here. And those are just two quick examples on factoring.